Exponents and bases. Now, for these first three examples that we're going to look at, in this case, the small numbers on the outside of this x, that's called an exponent. Represents repeated multiplication. Now this exponent of 2 is only on the x. The 3 also has its own exponent, but it's not a 2. If you want to put an exponent in for the 3, it would be 3 to the first. Now over here, the exponent is on the parentheses, which means that everything inside the parentheses is being squared, or raised to the third or to the second power. Now on this one, the exponent is only on the 3, not the negative sign, only on the 3. One way to think about this is saying the opposite of 3 squared. So on this one, there's no work to do. On this one, this is the same as negative 3 times negative 3, which is a positive 9. Now on this one, this is the same as negative 3 times 3, which is a negative 9. Some people get confused on this. The exponent is on the number, not the sign. Keep that in mind. Now these exponent rules, these are big time rules to consider. I'm going to show you the little tricks that I use. Some of these I don't use at all, or very rarely. I'm going to give you names to help you remember how to use these. I'm going to show you where these come from. Now this first rule basically says when you multiply like bases, you keep the base and you add the exponents. Now I'm going to give you a little example on why this is true. X squared is the same as x times x. X cubed same as x times x times x. If I ask you how many x's are being multiplied together, you would say 5. But a faster way to get to this 5 is to add the 2 and the 3. That's what this rule states. Now the second rule, if you look at it, is similar to the first one, except it involves division. So if you add, or when you multiply you add, and when you divide you subtract. Now I really don't ever use this rule. If I do, it's just for special circumstances. Let me give you an example why. X to the fifth over x squared. If you wanted to expand them, x to the fifth would be x times x times x times x times x. If I said that 5 times, I think I wrote too many. Over x squared, which is x times x. Now all I'm going to do is cancel. Those two x's are going to cancel 2 of those, leaving 3 x's multiplied, or x to the third. Same as 5 minus 2. But you'll find out that I like to cancel. I actually like to cancel my mind. Now this next rule, this says when you have one exponent raised to more than one, let me rephrase that, when you have one base raised to more than one exponent, you keep the base and you multiply the exponents. In fact, if I cover up that A, that M and the N looks like multiplication. It's kind of a way to remember it. So when you multiply, you add, divide, subtract. When you raise the power to the power, you multiply. A quick example is if I were to take x cubed to the second power. Exponent of 2 means that there's, and it's all parentheses, it means there's 2 sets of parentheses. Each has its own x cubed. If I ask you how many x's are there in expanded form, you would say 3. There's 3 there. There's 6 total. As you can tell, 3 times 2 is 6. So these are just examples on why the rules work, but the rules are meant to be shorter than having to do all this expansion stuff. Now this rule number 3, I use it quite a bit, and you will too, so just be aware. Rule number 4, the word I use is distribute. Much like the distribute property, when you're multiplying over addition to the parentheses, each thing gets its own number in front. Well, each base gets its own exponent. And kind of a simple example to consider is xy squared. Exponents on the parentheses, so I draw 2 sets. I have x, y in both of those. And I just multiply x times x, y times y. So the word to remember is distribute. Now number 5, anything 0 power is a 1. I got several ways to explain this. For time's sake, I'm just going to use rule number 2 to explain this. If I take anything, in this case x cubed, and divide it by itself, you know we always get a 1. But if I use the subtraction rule, because when I divide I subtract, 3 minus 3 is 0. Same problem, 2 different answers. That can only mean one thing. These answers are the same. X is 0 equals 1. In fact, anything 0 power is 1. And then this last one, rule number 6, is big time. It's a big rule to remember and to consider. I call this the flipping base rule. This a is actually an a over 1. So when you flip it over, the exponent changes from a negative to a positive. So in other words, when you flip the base, the sign changes. I call it the flipping base rule. To give you a quick example, let's look at x to the third over x to the fifth. I'm going to do this by expanding. There's 3 x's on top, 5 on the bottom. When we cancel doesn't mean they go away. Canceling means they reduce down to 1s. So what's left on top is a 1, and on the bottom we have x squared. Now, if I use the subtraction rule, what's going to happen here is I'm going to take that 3 and the 5 and subtract them, and we're going to get negative 2. What that tells me is that x to the negative 2 is equal to 1 over x squared. Same thing as saying, by that rule, take the base of x over 1, flip it over, and the sign becomes a positive and stays attached to the x. Now another example to consider right quickly with this negative exponent rule is one like this. Let's look at x to the third y to the negative fourth over z to the negative seventh. Notice we don't want negative exponents, so if we have negative exponents, we're going to flip the base. Anytime it's in fraction form, all that means to do, if you have a negative exponent in the numerator, when you flip it, it goes to the denominator as a positive exponent. If it's in the denominator, when we flip it, it goes to the numerator as a positive exponent. If it already has a positive exponent, keep it. So here we go. X to the third, it's already positive, keep it. Y to the negative fourth, negative exponent in the top, flip it to the bottom, becomes a positive exponent in the denominator. Negative exponent in the bottom, when we flip it, it's going to go to the top as a positive 7, and you're done. That's all that problem was asking.